Hello again, YouTube. It's been a while since I posted a video, but I thought now's better than ever to post a new Cryptography 101 video. So this one I'm going to be talking about hash functions, hash maps, and hash collisions, what they're for, what they do, and what benefit they have to you as a cryptography student. So to start out, what is a hash map? Or what is that? What is a hash function actually? Well, a hash function is a function that takes an input and converts that input to one unique output. So what that means is that a hash function is a one-to-one function in the strictest sense that for any singular number that it's given, it will never ever produce the same value. Now, perfect hash functions try to obfuscate the end result from the given results. So what a feature that's good in a hash function is if you want the hash of A, let's say you want the hash of the number 10, you should get some string of characters that doesn't uniquely identify 10. Also, you want to have a unique string of characters that doesn't come back to the same value. So if I give it the hash of 10, it should give me a different result than if I give it the hash of 20. It should give me a different result. And for the purposes of cryptography, what you would use a hash for is for storing things like passwords. Instead of storing the actual plaintext password so that if an attacker was to breach your database, you could store a hash of the password. And what that means is that if your database does get breached, the passwords aren't necessarily broken. Now there's a little bit more to that, and I'll be talking about that in a later video, but for now you can just assume that a properly hashed password is relatively secure, and you can't usually go from hash back to password. So now what do you use a hash for in the simplest form? Well, let's have a look at this hash function that I've written here. This hash function, what it does is it just takes whatever integer you give it, takes that integer, and then it runs a mod 10 operation on it. So what that gives you is if you were to give it a 5, it'll spit out 5 because 5 mod 10 is 5. If you were to give it 10, 10 would spit out 0 because 10 mod 10 is 0. So what can you use that for? Well, the first use case for it is what's called a hash map. And what a hash map is a hash map is an array. 2, 3, 4, 5, 6. So this is our array. And what we're going to do is we're going to use the output of this hash function as the index in the array that we're going to insert our element into. So if I wanted to insert the number 5 into the array, I would run it through my hash function and get the index 5, and then I'd go 0, 1, 2, 3, 4, 5, and I would put my 5 in here. So if I wanted to put 10 in there, I would go and run 10 through my hash function. That gives me a 0, so I can put 10 in here. And then, oh no, look, I want to put 20 in here. Well, what do? Well, I put 20 in here, and that gives me 0 as well. Well, I already have 10 in the table, so what do? Well, one way to solve this problem is to use a linked list. So if instead of an integer, we consider all of these as nodes, what we could do is we could add a node to this element, and we could stick the 20 in there. That's one option. Another option is that if we have a hash collision, we could add one. That might work in some cases. We might have a hash collision and we might have some special code in our hash function that we can run it through and say, this is a collision, do something about it, fix it. But in the general case, usually what you want to do if you get into a situation like this is extend this, make it a two-dimensional list. That'll make things a little bit faster. So the reason why you would want to do this, like why would you use a hash function instead of just iterating through an array? Well, so given this array here, we've got 10, and then, well, this leads to 20. And then we've got some number, and that continues until we get to 5, right? And these are out of order. So if our list is unordered, and we wanted to find, say, 5 in the list, which is the worst case for this particular list, what we would have to do is we would have to start at this list, and we'd go and search 10, then we'd go and search 20, then we'd search these numbers all the way over until 5, and each one of those operations would take however many elements are in the list. If we have a hash function, this hash function is constant time, so regardless of what number we put in here, it's going to take the same amount of time to run this. And then accessing an array is also constant time, so that will be that'll be O of 1 for the hash, and then it'll be O of 1 for accessing this array. So what that means is that we've now got a constant time method of going through and accessing elements in the array. We've got a constant time method of putting things in the array. We've got a constant time method of finding things in an array. And that becomes really useful in a lot of cases when you're doing things like traversals, or you've got a large data set where iterating over values is not something that you'd want to be doing very often if you've got to do, 100,000 operations. So what's the other use of a hash function? Well, like I was saying before with passwords, what you can do is say I've got the password. I know. Great. And I have a hash function that takes this and it turns this string of characters into let's say it turns it into 5 hexadecimal characters. So it turns it into 0xAF1, right? This is an imaginary hash function. There's no hash function that works this way. So if I know this hash function, what I can do is I can take the user's password here, pass it into my hash function, and then I can get my hash. I store this into the database, and I don't have to touch my user's password. So that means that if a hacker comes in and breaches my database, he only gets this. He only gets this 0xAF1. And he'd look at that and he'd say, I don't know what that does. I don't know what it's for. And it still also stops him from being able to log back in. Now, this assumes that there's no way to go backwards. It also is assuming that the attacker doesn't have access to this hash function. So both of those are pretty large assumptions. And for the most part, there's a lot of vulnerabilities if you were to try and write your own hash function. So this is not really something to do. So in a real website, well, how are the passwords actually stored? So what the passwords, what a normal real world website would do is it takes a hash function. Usually it's called SHA. Now there's 256. 256 is the one with the most bits at the moment. Well, 256 has 256 bits. I don't know if it's the most at the moment. There's probably SHA-512. But anyways, what SHA-256 will do is it spits out a character. It spits out a string of characters based on another string of characters. And typically what they'd also do with passwords is you would concatenate something called a salt. And what a salt is a random string of characters that's repeatable. So what you would do is you SHA the password and the salt, store that in your database. Then when the attacker gets it out, they have a really, really rough time getting their salt out. And typically what a salt will be is a salt is some value that's unique to the user. So you could use like a registration date, something like that. There's a lot that goes into what you make the choice of the salt. But typically what you do is you take a password, you salt it, then you hash it, send that into your database, and that's what you would use to authenticate your users. And the reason why you do that, like I said, is just to stop attackers from getting from getting this and being able to go backwards. So typically what the attack would be if you didn't have assault here is what an attacker would do is they would use something called a lookup table. And what a lookup table is it's they've gone through and they've just generated tons and tons of common passwords and the hash for those passwords. And then what you would do is say you breach this database. I get this. I go down to my, like, say I'm the attacker that breached this database. I get my password from your site. Then I go to my database of my hashed passwords. I send in OXAF1, and then I get password out of it. And now I can go back to your site, log in with the user information, and steal their credit card or post a stupid video on their account or something. So that is a hash function. That is the uses of hash functions. If you have any questions, please let me know. I'm trying to be more responsive to my YouTube channel as of late. It's been a pretty busy few years, but have a great day and good luck with your studies. If you have any video ideas, please let me know. I'd be happy to explain something if you're having any trouble. And I know that there's some of my videos flying around university campuses. Some university classes have put my videos in their playlists, and I appreciate that. It feels good to hear that. So as I said, if you guys have any questions, please let me know. I'll make a video on whatever you ask me to. And that's all I have for now. Have a good day, and don't forget to subscribe.